Okay, Assalamualaikum semua dan good afternoon.
Waalaikumsalam.
Waalaikumsalam, Doktor.
Good afternoon.
Waalaikumsalam, Doktor.
Sihat ya semua? Yes.
Alhamdulillah sihat Doktor.
Ya, Alhamdulillah.
Sihat, Doktor. Alhamdulillah.
So, I think kita ada total 30. Berapa? Check. Tadi nampak ada 37 orang. Tapi daripada sini tak boleh check. Baik lain from Dr. Jabbar. Okay, so baru 31 orang, but never mind. I think the rest akan join lah. Let's go. Kita boleh mula. So basically, kalau hari ini 18. Share screen. Stop broadcast. So yeah, guys, because I need to log in my tab, so that I can concede okay. So okay, let's start with our planning. Actually, I think I already have shared this information. Oh, I think I haven't shared yet, but I will share soon lah. Okay, this information regarding kita punya planning of quiz, test and the final exam. Semua boleh dengar guys? Semua boleh dengar kan?
Boleh, Doktor?
Boleh.
Okay, cantik.
Ya, Doktor.
Okay, so first let's come back. Let's talk about the quiz. Let's talk about the quiz. So our quiz will be only one quiz. Akan satu satu quiz lah. Akan jadi satu quiz. Is there any international student here? Is there any international student here? Anyone? No, eh? Okay. So kita ada satu quiz. So quiz akan jadi minggu ketiga, on the third week. If you can see, it will be on the third week. So which is on the 4th of April, Friday. Okay, hari Jumat. And this one of course will be online. Okay, kita plan nak buat author the MCQ and online. Okay, online. Online. So lepas raya lah kan? Lepas raya. So raya will be 31 kan? 31 so that's why kita nak plan yang sebab lepas raya kita ada cuti, tapi lepas cuti kelas macam biasa lah. Okay. So that's why we plan to do on the 4th April, Friday. So 9 p.m. to 9:20 p.m. Agak-agak 20 minit. Okay. Akan jadi 10 soalan. You will have a 10 question. Okay. You can have a 10 MCQ question. 10 MCQ question. MCQ maksudnya tahu kan? Multiple choice question. Okay, 10 MCQ question. So each question will carry 1 mark. So it will have 10 questions. But even though it will have 10 questions, 10 marks, we will take 6 marks. Okay, 6% from it. Okay, we will take 6% from it. Remember, eh? It will be conducted in author. As you know, this will be conducted in author. And time, I think you guys dah tahu dah, malam lah. Okay, so lepas Isya lah kan, senang lah lepas Isya, semua dah macam senang sikit lah boleh buat. So then our test, okay, we plan for the test. The test will be 24%. Okay, kita akan adalah kita test kita adalah 24% lah. Okay, duration 1,5 jam. And then yang test akan will be held on the minggu ke-9. Okay, 15 hari bulan 5. So please mark this. Okay, 15 hari bulan 5. Okay, 4th April is our quiz, which is on 9 o'clock. Yes, PQ quiz. And then Aida masuk dalam I punya kalender lah. So you pun boleh buat. Okay, masuk dalam kalender. I tak tahu you guys maintain kalender dalam Google Meet ke tak. Okay, kalau tak maintain, I think you should start doing it lah, to maintain in your calendar. In your phone kan mesti ada kalender kan. Google Meet atau Google Calendar atau apa kalender lah, mana yang senang. So boleh masukkan dalam kalender. Okay. So 15 hari bulan 5 is basically on hari Khamis. Okay, on Thursday. And the venue will be on F2 atas. Okay, kita dah book dah semua dah ni, benda ni. Okay. Dr. Jabbar kita punya pelaras dia buat meeting, lepas tu terus kita buat booking, semua tu dah siap dah. Then syllabus is chapter 2, 3 and 4. Okay, chapter 2, chapter 3 and chapter 4. So it will have 3 chapters. Okay, remember we'll have total 3 chapters. Chapter 2, chapter 3 and chapter 4. So question structure 3 soalan. Satu soalan 8 markah. Jadi total 24 markah. Okay. Faham guys? Ada soalan apa-apa?
Faham tak tahu?
Faham eh? Okay. Nice. So this is test. Okay. So So final exam, I will not discuss much at this moment. Cuma final exam will be chapter 4, 5, 6, and 8. Okay, chapter 4, 5, 6, and 8. So each chapter will have 1 marks. Okay, dalam final exam kita adalah 25 markah. So 25 kali 4 jadi 100. Okay, that is actually our plan. You might have noticed that there's a no assessment from 7 and 9, but actually have attendance 7 and 9, chapter 7 dan chapter 9. But chapter 7 and chapter 9 is basically included dalam project. Okay, tapi dalam project tu adalah chapter lain-lain juga dululah. Chapter lain-lain chapter pun adalah dalam project. Okay, so tapi there is no final exam, test atau quiz daripada chapter 7 dan 9. Okay, because we observe that the 7 dan 7 dan 9 are basically more on the measurement and in the simulation type chapters. So that's why actually we leave these chapters for the self-study and self-guided and for the projects. Okay. Then, so remember, okay, the syllabus is you remember the quiz, our quiz will be on the chapter 1, okay? Remember this, chapter 1. So maksudnya hari ini kita akan belajar chapter 1. So this chapter 1 is only for the quiz. So bila you habis quiz, so maksudnya dah okay lah, dah settle lah chapter 1. Kita payah ulang balik chapter 1 untuk exam. Okay? Senang kan? Kita punya assessment senang tak? Hey. Okay. Thank you. So now we see the RPP04. Let's see the RPP04. 1 minute. Let me open. Where is it? It's in my OneDrive. Power quality. It will be in the welcoming pack. Yes. Okay, so share balik. Okay, so we can actually see the. Okay, I cannot edit this. This RPP04. Semua boleh nampak kan? Nampak jelas ke tak?
Boleh.
Boleh Okay, nice. So nama khusus you guys dah tahu dah, of course, power quality, and the code khusus is BEV40603. This is synopsis is the subject introduces the power quality issues problems as they relate to the electrical power transmission and distribution system. So this one actually is related to the power transmission and the distribution system. So nanti kita akan bincang lah macam mana power quality to relate dengan transmission and distribution system. This course will provide students with overall understanding of PQ problems and how they interact with the system. So PQ problems actually PQ actually power quality though. Anything bila kita cakap pasal quality, benda tu relate dengan macam maintaining is punya quality again. So quality maintain maksudnya apa? Maksudnya basically we are maintaining quality by solving some problems, okay, or stay away from problems. That is actually the idea. Nombor satu, solve the problem. Kalau tak dapat solve, sorry, nombor satu, stay away from the problem. Maksudnya precaution. Kita tak nak jadikan problem. So this is number one idea. Number two, in case problem happens or problem occurs, then benda tu kita kena solve. Okay. So this is the one kita akan belajar lah mainly. Then another issue also is related, which is the identification of the problem. Kita kena identify juga lah the problem occurs. Okay. Problem occurs kita boleh rasa, tapi ke mana problem occurs, where is the specific problem occurs, and what kind of problem occurs, benda tu pun cerita lain. Okay. So this all kita akan belajar lah dalam kursus ini. In addition, possible measures to solve the PQ problems will be also discussed in this course. I think this is already mentioned. Okay, so you guys tahu I am one of the section 4 lecturer. So this subject is offered in year 3 tahun ketiga. Okay, and the prerequisite of the subject is the PE, which is the power electronics. So I'm sure all of you have completed the power electronics. So kita ada 3 CLO. I think you guys actually I should read the CLO, but never mind, I should read. So let me read it. That one actually kita punya procedure lah. Kita kena bagi tahu student at the beginning of the semester the what are the actually the course learning outcome. Okay, so let me read. A student will be able to understand the PQ issues and categorize them on the basis of international standard. Okay, so student will be able to develop the suitable solutions of PQ problems according to desired applications. Okay, and nombor ketiga is student will be able to analyze the PQ problems and propose their corresponding suitable solutions based on the standard and the regulations. Okay, so these are actually, you can see that you actually be able to identify the problems and solve it lah. So teaching method kita ada cara 3. Satu is a lectures, nombor kedua untuk CLO 2 is a project, nombor ketiga is a seminar. Seminar maksudnya presentation lah. Okay, so you can see that the CLO 1 kita akan assess through the quiz, test, final exam and the project. Okay, CLO 1 kita akan assess lah quiz, test, final exam and project. Then CLO kedua is the project, which is the PBL, the simulation, and the CLO 3 is the presentation. Okay, seminar atau presentation. So now the number of actually chapters, you can see the number of chapters we have. Total adalah 9 chapter. Total kita ada total 9 chapters. Just now you guys nampak kan, kita ada total 9 chapter. So chapter 1 dan chapter 2 kita belajar through online. The rest of the chapters kita akan belajar physical, okay, face to face. I know you guys semua memang semua puasa lah kan. Mostly, I mean the Muslim semua kita puasa. So mesti penat lah kan, atau mungkin ini benda lain. I try to finish as soon as possible. I try to finish it as soon as possible lah. Okay, but I have to make sure that I touch all the topics. That's also I can pastikan lah kan. Okay, so alamak, sini tak nampak clearly. Kenapa tak nampak clearly? Okay, never mind. I think assessment you guys dah tahu kan? Tak payah ulang balik lah kan? Assessment you guys dah tahu dah. So nothing to learn by leak. Then kita ada buku actually. Buku cuba yang teks buku boleh dapat apa dekat library atau soft copy pun boleh dapat. Okay, online you guys boleh cubalah. Yang first one, the Barry W. Kennedy. Okay, Power Quality Primer. Okay, it's a McGraw-Hill books. Walaupun 2000, you boleh dapat mungkin yang latest sikit lah. Okay, latest sikit pun boleh dapat. And the electrical power system quality pun ada. The Rosa C. Dugan buku pun I ada lah. Soft copy I ada. Okay, so this is the one. This is the one. Ada soalan apa-apa from daripada ini? Yeah, sorry. Someone asked question. Ada soalan apa-apa?
Tak ada, Doktor.
Tak ada, eh? Okay. So now let's go to the chapter. Okay, so I think I already open. I think chapter semua you guys dah dapat dalam author ke macam mana? Dah ada dah dalam author? Ada. I belum check lagi. Student learning materials. Oh yes, already. All the chapters you can find in author. Okay, Dr. Jabbar already dah upload lah, download dah lah dalam ini. Dalam author. So you can find all the chapters, but my chapter 1 is slightly different. Okay. Let me share with you. Screen. Okay. Boleh nampak semua?
Boleh Doktor.
Boleh, Doktor.
Okay. Okay, thank you. So our first chapter is Introduction to Power Quality. So let's go to the actual thing. First of all, kita kena fahamkan apa maksud power quality. Okay, apa maksud power quality? Is there anyone boleh jawab atau boleh bantu jawab? Apa you faham pasal power quality? In bahasa muda lah. Mungkin tapi in a simple word. Anyone? Benda tu you tak payah baca. Benda tu nanti I terangkan. You tak payah baca yang apa konsep. But first you tell me what is the meaning of the power quality. Any idea? Ada idea apa-apa ke? Boleh kongsi? Anyone? Ada? If you don't know, tak payah raise hand, just buka microphone, then boleh cakap. Level of consistency ni susah lah faham aku lah. Kalau bahasa muda,
Characteristic electrical power supply
sorry.
boleh refer to characteristic of a power supply.
Okay, good. Characteristics of the power supply, yes, boleh, good, boleh terima lah. Tapi lagi kalau okay, then I bantulah. Okay, lagi kalau kita lagi terangkan benda ni, apa maksud power quality is, you see, kita semua pakai electricity lah kan? Electricity kita semua pakai. This electricity actually datang dari mana? From where the electricity comes?
Dari TNB?
Dari TNB, okay, good. Boleh terima lah that. Actually, is you can say TNB. TNB actually is the one who manages this, but electricity actually comes from the generation side, right? There is some place the electricity is generating in a power generation. So it passes through all the transmission line, okay, transmission and distribution line. Then sampai dekat kita punya rumah, okay. So it is actually they are the service provider. So maksudnya kita bayar kepada TNB, then the TNB actually provides us the electricity service. Okay? That is actually the concept. So we are the consumer, and TNB is the main business partner that you says that the TNB kalau Semenanjung lah, kalau Borneo tu lain lah kan. So now what happened? The electricity that we are actually getting from TNB atau from power generation, that it has to be a good electricity. Benda tu memang kena good quality of electricity. Okay. Yes, generator. I say Abdul Azim. Yeah, you said that it's a generator. Yes, it's right. It's come from actually generator, right? The transmission, the generator side, the power generator, right? The power generator is coming from there. Okay. So the electricity that we are receiving, yang kita pakai kan, dekat rumah, dekat industri, dekat universities, sekolah, semua tempat. So electricity kita kena pastikan it is a good quality of electricity. Okay. So now tiba-tiba apa maksud buat good quality kan? Of course, the electricity also has to be a good quality electricity. Sebab kalau tak electricity quality tak bagus, then what will happen? Kita punya appliances, contoh kita punya appliances akan jadi rosak. Okay, our appliances memang akan jadi rosak lah. Maybe we have never thought about it sebab kita tak rasa. Tapi this is fact. Okay, this is fact. In Malaysia, usually electricity has a no problem. You have no problem of quality of electricity. Macam apa kita kalau electrical engineering kita panggil usually no problem of power quality lah. Usually lah. So far I nampak in Malaysia there is a no much fluctuation. No fluctuation actually. So far I never have any experience. But in many countries, actually, if you read the papers, in many countries has a problem of the quality of the electricity. Bukan maksud saya the lack of electricity. Benda tu lain. Okay. Ada satu negara yang ada electricity, lack electricity, tapi dia punya quality electricity tak bagus. Okay. Kalau quality of electricity tak bagus, so what happened? Dia punya appliances yang consumer, yang people, the consumer lah. Consumer guys tahu kan apa maksud consumer. So consumer, dia punya appliances, dia punya barang cepat rosak. Okay. Boleh jadi cepat apa dia contoh and a consumer as a consumer, let's say we are using computer, desktop computer for example. Okay, and the desktop computer, kalau kita guna desktop computer and you have a fluctuation of the voltage, okay, sebab desktop computer kita terus plug in dekat AC outlet lah kan, AC plug-in direct on the wall plug. Kita directly kita ambil power daripada situ. So kalau voltage level fluctuates, so the desktop computer akan restart. And what happened? Windows crash. Okay, tiba-tiba restart. So the Windows might crash. The power supply of the desktop might rosak. So it's a very common problem. Okay, this is a very common problem in the certain yang negara yang quality of the power tak bagus. Okay, it's not good. So So now come back to the PQ problem. So PQ is this, that the power, the yang electricity yang kita dapatkan dia punya quality yang bagus. So macam mana kita boleh nilaikan quality, kita boleh ukurkan quality macam mana? So kena pastikan dia punya voltage stabil. Okay, the voltage level is stable. Let's say 220 volt. So memang dia 220 volt. Okay, they suddenly not jump to 280 volt, or suddenly not jump down to let's say 100 volt. Okay, if any jump, later we will actually belajar. If all this jumping thing happen, fluctuates happen, then you punya appliance akan cepat rosak. Okay, let's say you buy one desktop computer. Okay, for example, you spend 8,000 contoh lah kan, 8,000. So one fluctuates happen, finish you punya desktop. Okay, that is actually is a big problem. That's actually a big problem. That is the one we are going to study. This number one. Number two, current also can spike. Voltage and the current. Current also could be spike. That also can spoil barang. Memang cuba boleh barang. Sebab bila current naik atau voltage naik, power of course naik. So the rating punya sensitive equipment, okay, sensitive equipment boleh jadi rosak. Okay. The number third is the most important thing. Okay, which is the frequency. Let's say the frequency is a 50 hertz and the frequency changes. Okay, little bit changes, 50 to contoh 50 ke 55 habis. Okay, a lot of appliances will spoil. Maybe kita at this moment, maybe we are thinking about barang yang kita guna, which is at house help. Okay, that is comparatively less expensive. Kalau you fikir pasal yang industri punya barang, yang industri yang dia punya barang yang billions ringgit, millions and billions ringgit. Okay, millions dollar worth appliances dia punya load. So kalau dia punya the barang rosak, dia macam mana? Okay, so now you can think actually how important the power quality is. Okay, now you boleh fikir macam mana the power quality is. So electricity of course kita ambil KNB supplying atau any utility company supplying, but the utility company memang kena pastikan that the electricity that is actually reaching to the end users must be good quality, must maintain the standard. Yang tadi kita, I don't know, you guys notice ke tak, bila baca yang CLO 1, dia cakap international standard. Ada satu kan CLO 1 yang ada term international standard. So maksudnya the electricity that you are supplying must be dia punya nilai, the quality of the electricity must be international standard. Sebab kenapa? Sebab barang yang you beli tu, contoh any sensitive equipment, contoh laptop, computer, tab, atau any atau different kind of appliances. Okay, barang you guys beli, bukan you beli from Malaysia only. You buy from Japan, you buy from America, you buy from different countries. So it means that whole world, okay, it means that dalam satu dunia mesti kena ikut some standard. Okay, so that these appliances boleh pakai by whole world. Faham? Ada soalan? Okay, so this is the actually idea. I don't know how much you guys boleh catch sebab you guys bukan depan saya, but macam depan, of course you guys depan saya, tapi virtually lah, virtually, tapi hopefully boleh faham lah. Okay, hopefully boleh catch up some. Now let's go back. I think the power quality issue, I think the power quality, the first chapter already 50% dah dalam I punya yang lecture yang I tadi bagi. 50% dah. Lagi 50%. Okay. InsyaAllah boleh siapkan dalam before 4 o'clock. Okay, sebelum pukul 4 kita boleh siapkan. So first you see I kasih ni ada ini long story, nampak long story. So long story yang I tadi cakap tu. Okay, if anything happen, if your electricity is not in good quality, it can actually cost you millions ringgit, right? Dia boleh memang kasih rosakkan you punya appliance, and that can cost you a lot of money. And this is actually, it happened in many countries. You can see in 1993, it happened in the United States. Actually, there are thousands, maybe I think ribu-ribu lah atau juta-juta lah ada case studies, ada cases, bukan case study, ada cases macam tu, the barang yang rosak. Okay. So power quality definition. So definition tu yang tadi I cakap lah kan, benda tu pun definition lah. That mesti kena ada good quality of your electricity. Okay. Is a study of powering and the grounding electronic system so as to maintain the integrity of the power supplied to the system. So maksudnya the electricity that reaching to the appliances must be in a good integrity of the power. Okay. And the IEEE yang I tadi cakap pasal yang standard lah kan, kita tadi kita cakap pasal international standard. So that international standard is the IEEE standard. Okay, IEEE ada standard, but we have other standard also. Nanti kita nampak ANSI, okay, standard. Ada few standard lah. The Japan, they have their own standard because they punya power ratings to line lah kan, so that's why they have their own standard. So IEEE, they have international standard. So almost all the countries around the world, they follow this standard. This is actually yang I tadi terangkan kan. You can see that this is the generation side. Okay, this is the generation side. The generation side, it comes. The electricity actually is produced, then it actually passes through all the transmission side and distribution side, through the transformer, all the circuit breakers, pass through all this, and then reach to the end users. Okay, this is the end user appliances. Okay, so you can see how from the production until the users, they need to actually pass through long way. So bila dia pass through all the way, now you can imagine the electricity of the quality must be disturbed. Quality must be reduced, must be changes. Okay, it is very normal that it will be changes. So in order to maintain the quality, okay, so a different kind of technology use. That one kita akan belajar lah in dalam chapter by chapter. Okay. So of course there will be some changes. So of course we have to use some technology, okay, so that the quality of the electricity doesn't change, okay, remain stable, doesn't change, they remain stable. That's actually the main idea of this subject. So it's more about PQ. I think this is already we are talking about this one again. Yang tadi I cakap that the maintaining power quality means mainly three things. Okay, voltage, current, and the frequency. The three are the mainly yang tiga benda tu kan mainly lah kan, voltage, current, and the frequency. So bila you nampak, okay, that any actually AC voltage, okay, bila kita AC voltage, so it is actually pure the sinusoidal, okay, it's a pure sinusoidal. So this is the one. Kan kita boleh nampak. I make it a highlighter. This is the one. So this is actually our sinusoidal again. And this is our actual sinusoidal. But tiba-tiba you guys can notice that we have another signal, which is this signal. Okay, we have this signal. So this is actually one cycle again. Yang ni one cycle. Yang actual, yang kuning one yang I bagi tadi. Kuning one to basically one signal. But you can see we have a harmonics here. Okay, yang harmonics yang si tengok nampak kat sini. Okay, so how many cycle here? Yang kecil tu. Who can tell me? How many cycle ada dalam tu?
3 cycle.
3 cycle. Yes, very good. So you can see it is actually consist of the 3 cycle. So macam mana yang I tadi tunjuk you here. Here we have one cycle. Start from here, habis sini satu cycle. Then sini ini lagi satu cycle. Then we have another cycle is here. 10. So 3 cycle. Okay. So this is actually harmonics. So since it has 3 cycles, so that's why kita panggil it's a third harmonics. Okay, it's a third harmonics. Your actual signal yang tu, yang kuning tu, this is your actually the pure sinusoidal signal. But tiba-tiba harmonic masuk. Third harmonic masuk. Bila kita cakap third harmonics is maksudnya dalam satu cycle dia akan ada 3 cycle. Okay, that's why we call it third harmonics. Kalau second harmonics, then kita panggil dalam satu cycle, it will have 2 cycle. Atau kalau let's say it's a fifth harmonics, okay, so dalam satu cycle nanti you akan nampak ada tiga cycle, ada lima cycle. Okay, this is actually the concept. So if it comes, harmonic comes like this. Harmonic comes actually in this way. Then we will study more about harmonic. We have a separate chapter on harmonics. So if it comes like this, okay, harmonics, then you see these two signal akan jadi campur macam ni. Okay, so dia punya actual signal will become like this. You see, you can see that this is no more a pure sinusoidal signal. This one, because it is combined with the harmonics. So if this, so that's why benda tu kita panggil the distorted voltage sine wave. So if this kind of thing comes, you punya sensitive appliance memang akan rosak. Has a chance that bukan memang akan rosak, has a chance that it will rosak. Because harmonics can spoil the appliances. So we need to remove the harmonics. Okay, memang kena filter out the harmonics. Memang kena filter out this harmonics. So we have a way to do that. That one, it will come later. Okay, it will come later. Actually, remember that all this actually power quality, I wanted to say about it. All this power quality, guys, everyone, please attention. I tahu you guys susah nak attend, tapi little bit lah, sikit lah, because the main thing I'm talking at the beginning. Okay, so that mula-mula you guys ada attention lah kan. So main thing I want to talk about this one first. So you see the sensitive equipment, we are actually worried about the sensitive equipment. So sensitive equipment maksudnya yang I tadi cakap, laptop, computer, battery powered, anything, mostly battery powered, the electronic component. Okay, that is actually the most sensitive power. Because why? Because electronic component usually 5 volt, 9 volt, 12 volt macam tu. Okay, but if you use any motor, usually motor is mostly AC powered. Okay, 220 ke atas, 230 macam tu, 240. So aircon pun sama lah, usually okay lah. I mean they can actually tolerate. Okay, they have the equipment to tolerate. But uh, kita punya laptop, computer, and other electronic components are very sensitive. Okay, so when this kind of actually harmonics comes, then the you punya sensitive equipment akan jadi rosak. Okay, that is the one benda tu kita cerita lah. Yang less sensitive electricity consuming equipment, like motors and the incandescent lights. You know, right? Incandescent lights. Kita kan yang lampu yang kita sebelum ni pakai lah. Nowadays we don't use. All the incandescent lights lampus are already omitted. So okay, I think this is what you already cerita dah. I tana cerita lain. So cuma harmonics can be mitigated. Okay, mitigated. A little bit more, I think I already tadi I cakap that the power system harmonics, the current or voltages with frequencies that are higher multiples. Sorry, that are higher multiples. I mean the integral multiples lah, which is the 0, 1, 2 up to n. Okay, up to n of the fundamental power frequency. So maksudnya you punya fundamental is satu, yang ni you punya fundamental, yang ini nampak, ini nampak fundamental, tapi harmonis datang the integer multiple of the fundamental. Okay, integer of the fundamental. So kalau contoh fundamental is 60 hertz, the first harmonics will be the 60 hertz, second harmonic will be 120 hertz, and third harmonic will be 180 hertz. Okay, that one actually will happen. You can see that they become like three frequencies, third frequencies. Mostly these third harmonics are third harmonics are mostly generated in the power supply. That is actually the people say that's actually the main concern. But it can be mitigated. Harmonics can be mitigated. Why bother about harmonics? I think this one tak payah cerita sebab of course lah ada cerita kan, benda tu you guys dah faham dah sebab most of our electrical equipments in a country are non-linear type loads. Non-linear type loads maksudnya yang tadi saya cakap tu, the sensitive equipment. Okay, this is the non-linear type loads. That's actually the main concept. Okay, so the loads that producing the harmonic currents. Loads that producing the harmonic currents, there's you can see the lighting ballast, and then the adjustable speed motor drivers, electric arc welding equipment. This one you can just you can inilah you can belajar sendiri. Okay, UPS, the uninterrupted power supply, industrial process control system. These are actually the main, the transformer, separated in the inductors of the transformer. This is actually the load that produce harmonic currents. This one actually I can delete because I think this is a okay. So I think this is also we discussed about it already. Okay, the power quality you have to maintain with the consumer load because the consumers are the one who are using the load. So voltage quality, current, and the frequency quality, this one has to maintain. That is actually the reliability. Okay, power quality maksudnya reliability. So kita rely lah kan, kita rely on the TNB or utility. Okay, that's why kita boleh pakai kita punya expensive appliances or loads. I think this all we discuss. Okay. This one is just a theoretical knowledge, steady state phenomena attribute and non-steady state phenomena attribute. That one you can just see. I think you know what is amplitude, frequency, spectrum. All I remove in this chapter basically adalah berapa almost 100 slides, but I remove actually. Okay, modulation, rate of rise, duration. I think all of this I remove. It's not really important. Okay, classification of PQ problems. There's some classification. It's just for your knowledge. Okay, and this one nothing to talk much. So reasons for concern with the PQ. Okay, this is also we discussed lah kan. Of course, memang kita ada sebab lah kan. Kenapa sebab? Sebab tu apa? PQ kita kena think about the power quality. Sebab apa? So the simple answer is kita nak safekan kita punya barang, kita punya appliance, expensive, sensitive equipment. That is actually the main concern, kan? That's the main concern. So end user equipment become more sensitive. It is okay. Large computer system, many business facilities, power electronics equipment for enhancing sustainability. This is the one we all discussed lah kan, tadi kita bincang. Recent source of PQ problems. Okay. This is the recent source of PQ problem, sources of PQ problem. So the modern load and the equipment are more sensitive to PQ variation, high efficiency adjustable speed motor drives, and the shunt capacitor results in increase in the harmonics level. Okay, so you can see that we have the sensitive equipment, number one, and number two is on the other hand, we have the high efficiency adjustable speed motor drivers and the shunt capacitors we use. That one we will see what is the shunt capacitors, everything. That nanti kita akan tengok lah, ada bincang. So that's actually the causes of the harmonics level. Then nomor tiga, they increase the awareness of the PQ issues by the end users. So another side is now the end users, they know about the PQ, the awareness things. So this all actually has to be balanced. Okay, that is the one we want to mention here, the recent source of PQ problems. Okay, so sources of PQ problems, internal costs. Approximately 80% of electrical disturbances originate within a business facility. Example, the large equipment startup or shutdown, improper wiring and the grounding, and overloaded circuits or the harmonics. So this is our internal problem. That means this problem are occurring from the end user side. Okay, that we are using the large equipment. Okay, that is actually startup or shutdown. The time is startup and time is shut down. So that time actually it from the user side actually it creates the harmonics. Okay, that is the one internal cost. And external cost, which is only 20%, the PQ problem originated within the utility, transmission, and the distribution system. So 20% is only from the transmission and distribution, such as the lightning strike, the equipment failure, the vehicle accident, weather condition, neighboring business, and even normal operation of utility equipment. So let's say one vehicle tiba-tiba dia langgar dengan tiang. Okay, there's an accident. Weather, one of the condition, maybe storm, then after lightning strike, then neighboring business maksudnya someone is building rumah ke apa ke industry ke, so tiba-tiba he make a calls of the in the transmission side. That is only 20%, but 80% are happening from the user side. Okay, because anytime we are shutting down our computer, not computer, I mean our system, start our system, tiba-tiba kita turn on kita punya factory punya aircon system. After that, matikan engine, matikan generator in the industry lah. So that is actually 80%. That's actually the main cause of the harmonics. So that harmonics actually passing it to the other people. This is a curve. Okay, this is a curve. Is a CBMA curve. It's a Computer Business Equipment Manufacturers Association. Okay, they came up in 1970, a curve something like this, that because these computer people, bila they manufacture the computer earlier, they are worried about this, they punya yang sensitive equipment dalam computer tu tak akan rosak, okay, tak akan rosak from the high power or fluctuation of the electricity. Okay, so they came up with a word that, okay, so it should be reasonable is this part lah. Okay, reasonable, it should be, this is the acceptable range. Okay, this is the acceptable range here up to here. This is time actually. They give one range. Okay, so all the power, anything fluctuate happen should be acceptable here. If outside, this is unacceptable. Okay, this is also unacceptable zone. You see internal sources of PQ problems causing the harmonics. So these are the actually sensitive equipment. Number one, they are causing the harmonics. Number two, they are also can be affected by the the PQ problems. Okay, so one is this one ASD, the adjustable speed driver, then computer, all the DC, mainly the the DC component. Okay, high efficiency lights. High efficiency lights is the light that one actually currently we are using. That is the one. Then microprocessor control equipment. Okay, so these are the one actually this the nonlinear type and the loads are the main causing of the harmonics. This is the external, right? Yang tadi kita bincang lah kan, isi tengok external lightning, all this. Okay, tiba-tiba jatuh, accident, arcing devices, and other things. This is, I think, fine. Okay, so the typical types of the PQ. Okay, PQ issues, typical types of PQ, power quality. You see that these are actually quite important. This is actually important for your inilah quiz lah mainly. So the voltage flickering, harmonics, voltage sag or the voltage swell, and the transient. Okay, so we go see the voltage sag. Semua ada guys? Ke dah tidur?
Ada.
Ada?
Ada doktor ada.
Ada sikit je lagi. Dah siap dah.
Okay.
Sikit je lagi. So, minggu depan pun ada kelas lagi lah kan? Oh, interesting thing I forgot to discuss. We are planning to go for industry visit, which is at Malakoff power generation. Malakoff power generation. Actually, it is Malakoff power generation. And this is Johor power generation. Enjoy. It is I think this is the Sultan Iskandar, I think. I lupa. This one. SPG power plant grant. I think SPG, bukan SPG. I think, jap, I tanya, I check that. Zarif. My student is, my Tanjung Bin Energy Power Plant. Tanjung Bin Energy Power Plant. Okay, this is the one. Well, every time is asking this question. So I think this is the official website. So we are actually planning to bring you guys here. Planning to bring you guys this place. You can accept that. So we are planning to take you to these place. Okay, there's one student alumni, my ex student. He's working here now. So we contacted him. He asked us to send us an email. See how we can, whether we be able to take you guys. But it will be in Pontian. Tak berapa jauh lah, dekat lah, dekat Pontian. So, but only one problem. Okay, ada satu masalah lah. The problem is it will be only limited to 40 students. Okay, limited to 40 students out of yang kita punya semua section lah. Kita ada total 4 section kan. So first serve, first come first serve. Because kita plan ambil satu bus. Okay. So maximum maybe 50 lah maximum, let's say, because nanti kita ambil kereta juga. So let's say I take kereta, Dr. Jabat take kereta, so some of you boleh tumpang lah. So maximum let's say 50 people. 50 student boleh muat lah. So first apa? First come first serve. That is actually our plan. So our plan is to visit is on Monday. Okay. And somewhere in Monday, I'm not sure which Monday, I forgot when is the date. I forgot to discuss with Dr. Jabba. So we need to do, so we have some process of work lah, like kita kena buat kertas kerja untuk dapatkan bus dan dapat some duit lah untuk pocket money, let's say we punya makanan, breakfast, tengah hari makanan daripada faculty lah. Itu je lah. So, and maybe some of the souvenir maybe, okay, because we'll be visiting some person over there. So, exchange some souvenir lah with them. Okay, faham guys? So, nanti bila kita post ini, bila kita post the link, so terus isi lah. Okay, first come first serve. But it will be on Monday. You guys ada kelas on hari Monday? Hari Senin ada kelas? Ke tak ada kelas?
Ada tak?
Tak ada
Alamak.
doktor.
Alamak, kalau ada kelas tu then susah lah. Guys ada kelas. So that is actually see how lah inshallah later on. Okay. Okay, now let's go back to our topic. This is ada lagi sikit je, okay? So this first time is the voltage sag or the dips. Okay, voltage sag. Oh, I also want to show you a little bit. We also, that is actually me and Dr. Jabbar, we are planning, which is the hydropower in Sarawak. Okay, it is called, why all the time asking for this? I think this is the one, come on, Joanna. No, not this. I think this is the one. Yeah, this is the one. We are actually planning, but not this website. This one, I guess. No. This one, why are every time is problem? This one is in Sarawak. This is called wait, and not this website. This is the one I drew, but it is in. It is in Sarawak. This one is Bakun. This one is called. This guy hasn't replied us yet. This is also our student. He's also working there. It is called. Bakun Hydro Plant. Bakun Hydro Plant, Sarawak. This is the one. This is the one, man. This is the one. Yes, this is the one. So anyone is here from Sarawak? Ada siapa-siapa daripada Sarawak sini? Siapa?
Hafiz.
Hafiz.
Hafiz bukan I punya student ke Hafiz? I see, Hafiz. Nice to see you, Hafiz. So Hafiz, ada lagi siap? Okay. We are planning actually, me and Dr. Jabba, we are planning only to go to Bakun. And also, Dr. Jabbar, he has a student, he's working here now currently. Kita punya alumni FKE. So, see how lah. Okay. Kita benda tu boleh jadikan ke tak. This is one of the, this is the biggest hydropower lah kan, hydropower. Tapi ini bukan dekat Kuching, ini dekat bukan Miri, ke mana ni? Ya, Bintulu. Okay, it's in Bintulu. So you can see that this is actually huge, very huge. Hafiz, pernah pergi sana, Hafiz? Tidak, jauh sangat. You must visit, Hafiz. You must visit this place. Tapi mesti kena dapatkan approval dulu lah kan. Kalau nak visit memang kena dapatkan approval di situ. So yesterday I got my section 3, ada satu student dia buat LI di situ. Okay, dia buat practical di situ. His name is Yie. So he told me that he spent 7 days over there, okay, to do the measurement, the water level measurement and other thing. He gave us some good, he shared some good experience, okay, about the Bakun hydropower plant. So that is, so you can think actually, so this kind of actually power plant, once we have it and the electricity generates from here and come all the way to our house, so how to maintain that is quality, right? How to maintain is stability and the quality. So this also a very nice place lah. Okay, let's talk about the voltage sag or the voltage dips we're talking about. The voltage sag is something that the reduction in voltage for a short time. It's a very short time. It's a between suddenly reduce in between. I mean between 1 minute to 8. I mean it happened in less than 8 minutes, but more than 8 milliseconds. Okay, that means half cycle, only half cycle. If you calculate, it will be around half cycle. Okay, so the magnitude of the reduction is between 10% to 90% of the normal RMS voltage at 60 hertz. Okay, I take it from the 60 book, so that's why still they maintain and they mention about the 60 hertz because some country they follow 60, some country they 50 hertz. So you can see there are some questions there. How do voltage sag differ from the voltage reduction disturbances? The voltage reduction disturbances is different than the voltage sag. Okay, you can fahamkan the voltage reduction disturbances benda tu lain daripada voltage sag. Macam mana? Sebab that voltage yang reduction disturbances benda tu akan jadi frequently atau periodically. Okay, akan jadi tiba-tiba datang lah. So that is actually the reduction disturbances. Tapi voltage sag they usually once, okay, and very short time, usually once. So that one time can spoil everything lah. Okay. So what are the causes of the sag, voltage sag? The voltage sag can occur mainly basically from the transformer failure in the utility side. Okay, but once it is the fault is, once let's say fault is recovered, okay, by circuit breaker or any other way the fault is recovered, then the voltage the voltage sag is already gone lah, because it's very short time, everything is less than 1 minute. Okay, it's less than 1 minute. So how you can solve the voltage sag problem? You can use, for example, the DVR, okay, dynamic voltage restorer. I think you know this one. This one you can buy in the Shopee also. Dynamic voltage restorer, or you have the UPS. UPS one bole dapat, okay, uninterrupted power supplies. Actually, many houses they use it. Many, I don't know whether you guys have experience to use it, but if you have any problem, this kind of voltage sag problem, so UPS can actually solve this one, because it's actually very for short time. So so UPS can solve, but IPS is different. IPS is instant power. So IPS is, let's say, tiba-tiba tada current. Let's say contoh semalam lah blackout dekat Taman. I don't know any one of you are here from Taman. So apa, sebelum buka puasa semalam tiba-tiba blackout. So let's say IPS is actually that because inside the IPS it has the battery, so it can support you the electricity for a certain time. Okay, for a specific load lah, not for all the loads. So this is actually the the graph. You can see that actually tiba-tiba they drop. Okay, very short time. The time is very short. 0. How long? The duration is 0.117 second. Okay, very short. So you see very short, they become normal. Then second is the voltage swells. Okay, swell. Voltage swell or the momentary voltage over voltages. Swell maksudnya apa? Swell. Swell. Anyone tahu apa maksud swell? Sometimes kita cakap lah, you dapat swell on your ni macam apa, on your badan lah sometimes. Swelling. You know the swelling? You know the swelling? Macam bengkak. Yes, bengkak. Right. It's bengkak. Right. Aqua tadi. Siapa?
Nabila, doktor.
Oh, Nabila. Oh, sorry. Yeah, Nabila. So it's actually bengkak lah, swelling. So bengkak maksudnya dia jadi naik lah kan? Mestilah naik lah kan? So voltage also naik. So that is actually swelling. That exceeds 110% of the nominal voltage. Can you imagine how much? 110%. Okay, of the nominal, how much spike it will be, and lasts for less than 1 minute. Okay, for voltage swells occurs less frequently than voltage sag. So voltage sag occurs, it can happen frequently, tapi swell is less frequently lah, lagi less. So it can often overheat the equipment and reduces its life. Yeah, you can imagine if the voltage dia tinggi, memanglah barang akan jadi bakar atau overheat lah kan, sebab over voltage. So it will reduce its life. So swells, you can see that it can happen. It's a single line to ground fault. You can see it's a single line to ground fault. Tiba-tiba satu tree dia apa, growing lah kan, tiba-tiba the tree is growing, so one of the line actually become fault. One of the single line is become fault lah due to this POCO, because it can happen in the transmission line, and due to this happen transmission line, it can affect our users, but usually have the circuit breakers and other things they can actually handle lah. Transient, okay, another important term. A sudden increase or decrease in current or voltage characterizes them. Okay, transient. You can see that is increase or decrease in current or voltage. It can destroy our computer chips and the TV. So transient or surges are sometimes referred to the spike. It less technically correct language. Okay, anyway, and it can happen in spike, but it's not actually spike. We call it transient. In electrical, we call it transient. They often dissipate quickly, but anyway, it has two types, okay, impulsive and oscillatory. So the most frequent cause of impulse transient is the lightning stroke. Okay, kalau lightning stroke, of course lah, the voltage they can tinggi kan, even though it's a very short time, but it can, the voltage boleh spike lah. I have mentioned all the details. You guys, kalau you belajar boleh faham lah. Ini tak berapa susah. Okay. Oscillatory pun ada bagi nota lah. So you just baca lah. You can see the gambar-gambar. Dah habis dah. Okay, lightning. So cloud is, you can see the negative charge. Okay, flow of the negative charge is past the earth. Its surface is a positive, right? So it can pass. That's actually transient light. Okay, this is the and this is the transient faults and the overvoltage transient due to fault current interruption accompanied by oscillations at the natural frequency formed by L and C. L and C, you know, the this one we will discuss later. Just put the picture here. This is a high frequency, you can see, and this one actually comparatively low frequency, not much frequency, but I mean the frequency here, but here you have actually high frequency. We discuss later during the motor starting time. Okay. So standard, I think why PQ standard we need, I think that one we already discussed. Kita dah bincang dah. Sebab kalau kita tak ikut standard, mestilah different negara they akan come up with the different appliances, then kita tak boleh pakai. Mesti kena ada standard. Okay. So standard is here. You can see IEEE, IEC, and ANSI. Okay. Besides this, we have other standard also. This one is just a 3 standard we mentioned here. Tapi ada lagi standard lah. Tapi mainly IEEE standard is the one that internationally followed. Okay, so you can see the yang standard itu dia ada nilai-nilai lah. Okay, dia ada typical voltage magnitude, typical duration, how long, typical spectral content. Dia ada nilai-nilai. So bila the any utility dia nak apa supplykan dia punya electricity, so they can maintain this one. They can maintain that the electricity is within this range, so that you have a good electricity. Okay, you have a good power system. You have a good power in reach to your house. This is IEC standard. Okay, then finally finish. Habis. Itu je chapter 1. Okay, chapter 1 kalau you tengok dalam, I think author, I think you will have a many maybe. Kalau I tak pasti, so I can ini login. Anyway, nanti you login lah. Nanti see. So nanti mungkin ada many lah. Okay, slides. But I make it concise so that senang lah boleh belajar. Okay, ada soalan apa-apa? I think here I have many of my known student. I nampak. And Hafiz is number 1. Muhammad Nur Akmal I kenal. Amirul Syafiq, ini siapa Amirul Syafiq? Lupa.
Ya, saya doktor.
Sebelum lepas you masuk saya punya transfer sakit?
Tak.
Ada 2 Amirul Syafiq. Then many of you I know. Anyway, Aiman, Muhammad Aiman, I think I kenal you. Alif Nazmi I kenal. Daniel, I see I kenal. Fakhruddin, I punya Fakhruddin lah kan? Kita punya MPP Fakhruddin lah kan?
Ya, doktor.
I see, Fakhruddin. Nice to see you, Fakhruddin. Hafiz I kenal. Hazmi pun ada. Hazmi ada.
Ada, doktor.
Oh, good, Hazmi. Okay, I then Nur Hikmatul, I think I can see many of you I know. Nur Nabila, Aqua kenal Tongchie Ik. Tongchie Ik, I'm not sure. I think Tongchie Ik, did you join my class earlier? No? Ik?
Dulu lab ada lab.
Oh, lab, I see, lab. Yes. Okay. Anyway, I think I most later bila kita jumpa face to face nanti akan kenal semua. Okay. So that's all for today. Okay, insyaAllah kita jumpa lagi minggu depan with the chapter 2. But chapter 2 akan masuk test lah. So chapter 2 we have to really study betul-betul lah. Okay. Then tapi chapter 1 you guys memang test tu quiz tu memang open book. Remember, quiz memang open book. Tapi masa nanti may not be cukup lah kalau you nak ambil tengok nota-nota semua atau slide-slide. So that's why later on I will advise to have a good preparation on chapter 1. Okay, so I want all of you get the full marks lah in quiz. Okay, 6 out of 6 inshallah semua. Okay, thank you so much. Thank you. Terima kasih semua. Have a good day dan selamat berbuka puasa.
Thank you,
Assalamualaikum.
Terima kasih.